An AI system so exposed that attackers didn't even need to guess. The system itself told them exactly what they needed to know. And once they had that information, they used it to manipulate the AI system's own memory. From there, they simply executed their own code remotely, as if the system belonged to them. We're breaking down 3 CVEs, not 3 isolated bugs, but 3 connected steps in a single attack chain. One that starts with an information leak, moves on to memory manipulation, and ends with full remote code execution on an AI system. All 3 bugs were inside the NVIDIA's Triton inference server. That's NVIDIA's software for running AI models at scale. It loads models, runs them on GPUs, and sends back results. The word inference just means what an AI does when it makes a prediction. You give it input, it gives you output. This chain starts with CVE-2025-23334, where an attacker leaks tiny fragments of memory. With that information, they move to CVE-2025-23320, pushing past shared memory limits to tamper with the model's state. And finally, CVE-2025-23319, a critical write that can overwrite memory and let an attacker execute code on the server, remotely and without logging in. Researchers at Wiz discovered the chain in early 2025 while analysing how Triton handles untrusted inference requests. On the CVSS scale, it's scored in order 7.4, 7.8, and then 9, critical. So you can see how the chain gets progressively worse. And the chain went like this. Step 1. Information leak. Starting with CVE 2025-23334. It starts with an out-of-bounds read. A crafted inference request makes Triton peek at a small area of RAM it shouldn't touch. That doesn't return source code, it returns raw bytes. Tiny scraps of memory that act like index cards. Those scraps give an attacker a map of where important structures live in memory, enough of a blueprint to plan the next move. Step 2. Memory manipulation. Moving on to CVE 2025-23320. Using that blueprint, attackers exploit a shared memory limit bypass to push the engine past its normal protections and begin changing memory outside of the safe region. In plain terms, the system's fences aren't checked properly. Now, they can alter the server's state in a predictable way. Step 3. Remote code execution. Ending with CVE 2025-23319. Finally, the attacker triggers an out-of-bounds write. A payload overwrites critical memory and hijacks execution. The server then follows that instruction and runs the attacker's code. At the point the server executes arbitrary code remotely, without authentication. Alone, each flaw is dangerous. Together, they form a full takeover. No confirmed attacks were seen. Wiz caught and disclosed the chain before any confirmed attacks. They proved it worked in the lab. But if the bug hadn't been reported and patched, it almost certainly would have been abused. The fallout was immediate. Security teams at AWS, Google Cloud, and major research labs rushed to audit every Triton deployment, worried an exposed endpoint was already marked for attack. Analysts warned that if it was abused, this chain could have led to stolen models and tampered medical results. The Register called it a wake-up call for AI security. Wiz, the team who found it, described it more bluntly: complete compromise of the AI stack, from model to hardware, using nothing but inference requests. The remediation costs alone ran into tens of millions, especially in healthcare and finance, where systems had to be recertified after patching. NVIDIA patched all 3 vulnerabilities in June 2025, just weeks after disclosure. The fix worked in 3 layers. Stricter memory checks, making sure Triton can't read or write outside the space it's supposed to, closing the out-of-bounds loopholes. Safer shared memory handling, removing the weaker logic that let attackers push beyond the normal limits and tamper with data in neighbouring memory. Blocking untrusted code. Attackers could slip in their own code for the server to run. The patch shut that down by only allowing code from a strict, approved list. Before, Triton was too trusting. After the patch, it double-checks memory boundaries, keeps requests fenced in, and only loads code from sources it knows is safe. but organisations reported slower performance. It fixed the chain, but with a small hit to speed. This attack chain forced the industry to realise that AI isn't just software in the cloud. It can be attacked at the hardware and system level just as easily as the model layer. It showed that you don't always have to hack AI model itself. If you compromise the inference engine running beneath it, you can get the same control, sometimes with even more power. And with AI on the rise, we're still vulnerable. There will be more flaws like this, but after Triton, the mindset shifted. So that's how 3 small vulnerabilities could have become a full takeover of a production AI system. Just a clever chain, a tiny memory leak, and suddenly the attacker is running code on a victim's GPU. The AI model itself was never touched. The exploit went for the engine underneath it, the thing running the model. That's where the real power is. And that was CVE-2025-23334, CVE-2025-23320, and CVE-2025-23319. 3 for the archives. And if you enjoyed this, we have new CVE breakdowns every week. Subscribe so you don't miss out, and give this video a like. I'll see you in the next one.